Okay, YouTube, in this video we're just going to look at running through a few examples of simplifying complex fractions here, starting with this one right up over here. So let's go ahead and start and take a look at what we have here. It looks like we have a difference of two fractions over a difference of two fractions, so definitely a complex fraction. So let's recall that our methods here are twofold. One is that we could go ahead and just simplify the top expression into a single fraction and simplify the bottom expression into a single fraction. And once we have a fraction over a fraction, we can just multiply by the reciprocal here. So in terms of simplifying the top and the bottom, let's go ahead and separate these out here. We say the numerator, let's go ahead and simplify the numerator expression over here. We have x over 6 minus x over 3. So recognizing that the least common denominator here is 6 is actually kind of an easy thing to do. So we'll go ahead and multiply this right expression by 2 on top and bottom. So we get x sixths minus 2x sixths. And what we end up with here is, I guess, sixths, where we get x minus 2x is a negative x here. So I'm going to put a box around this. But that is exactly what our top expression then equals. Let me see if I can write on this here. I can. All right. So, I could. Let's try this again. So the top expression here, we get a negative x sixths. And on the bottom here, let's go ahead and do our denominator expression. Denominator. And so for our denominator, we have x fifths minus 7 tenths. And so again, a little bit easier to see, our least common denominator here would be a 10. We would get 2x over 10 minus a 7 over 10. This leaves us with 2x minus 7 all over 10. So I'll put a box around this as well, and we'll say that really this is what we have over here. We have 2x minus 7, all of this. Let me put this over a 10 first, and we'll put parentheses around it. So now, because what we've got is a fraction over a fraction, what we could do is we could actually just rewrite this as multiplication by the reciprocal. So instead of negative x over 6 over 2x minus 7 over 10, we're going to do negative x over 6, okay, times the reciprocal of 2x minus 7 over 10, which is 10 over 2x minus 7. So with what we get here, let's go ahead and multiply these straight across. It looks like we get a negative 10x on top, and on bottom we get 6 times 2x minus 7. And of course, because we noticed that our negative 10 here and our positive 6 have a common factor of 2, we would divide both by 2 here. And what we end up with is this negative 5x over 3 times 2x minus 7. Okay, so that method there, we just went ahead and combined the fractions on the top and the bottom and multiplied by the reciprocal here. What I'd like to try in these next two examples is actually our second method, which was instead of just simplifying the top and the bottom and multiplying by the reciprocal, which we can do, let's go ahead and do this. Let's find the least common denominator between all of the fractions in the numerator and all of the fractions in the denominator. So let's remember something also, that the least common denominator is really the least common multiple between all of these denominators. So the neat thing about it here is we would see that all of these denominators are currently factored. The biggest factor of x we see is x to the first here in both of these denominators, and then these two denominators here, they both just have a 1. So I suppose we could put 1 on the list, but our least common multiple is just x. So the way this works is we're going to take the top and the bottom of this fraction times x, just both parts, which means we do need to distribute here on top and bottom. And this x is over a 1 in either instance. So the way this looks is if we take 2 over x times x over 1, we get 2x over x. Now minus, if we take 4 over 1 times x over 1, we just get 4x here over 1. So 4x over 1. Now, that's everything in the top. If we look on the bottom here, we get 2 over x times x over 1. We get 2x over x. And we have plus 3 over 1 times x over 1 is plus 3x over 1. So simplifying these, the neat thing about it is that these factors cancel out here, and then this 1 doesn't really matter anymore. So we would say that on top we have 2 minus 4x, and on bottom here we see that these x's cancel out, and this 1 is no matter here. So we get left with 2 plus 3x. So our simplified form of this is just going to be this guy right here. And that would be the same thing we would have gotten had we found a common denominator on top and subtracted those, and found a common denominator on bottom and added those, and then multiplied the top by the reciprocal of the bottom. So again, with number 12, I'd like to use this least common denominator method where we take the top and the bottom of this fraction times the least common denominator of everybody here. So you notice I write LCM because the least common denominator is the least common multiple between all of the factors in everybody's denominators here. So looking at everybody's denominators, I notice that this up here has an x plus 5 as a factor, and it is to the first power. There are no other x's plus 5. being raised to anything higher than 1. So this is the highest power of our factor x plus 5, and our highest power of x minus 3 here is x minus 3 to the first. I know that I don't see any other factors in these denominators here, so what we're going to do is we're going to take the top and the bottom, everything in the top, everything in the bottom here, and we're going to multiply it by both x plus 5 times x minus 3. And by taking both the top and the bottom times this value here, what we're seeing is that we are not actually multiplying by anything other than just 1, because anything divided by itself is 1. So putting these over 1 themselves, because we can do this here, let's go ahead and multiply these through, and down here we're going to have to distribute. What we get on top is this. We get 3 times x plus 5 times x minus 3, all over here, x plus 5 times 1. So our new numerator expression is this here. And as we go down to the denominator, we would get 2 times x plus 5, x minus 3. So 2x plus 5, x minus 3, all over this x minus 3 here. And this is all plus now. 1 times x plus 5, x minus 3, so x plus 5, x minus 3. And this is all over x plus 5 right here, x plus 5. So what we're going to do is we're going to go ahead and simplify these expressions here and see what we end up with. In every possible instance, because we did multiply by the least common denominator of everybody, I have to tell you that I can guarantee that you will not be left with denominators in each of these individual fractions anymore, because they will have to cancel out with factors that we saw existing before. So on the top here we get left with 3 times x minus 3, and on bottom we just get left with this 2 times x plus 5, so 2x plus 5 plus, and we got left over here x minus 3. So the way this works is we just go ahead and simplify the top and the bottom. On top we get 3x minus 9. And on the bottom here it looks like we get 2x plus 10, 2x plus 10, plus x minus 3. And we'll go ahead and combine our like terms here. We get 3x minus 9 on top. And with these here, we get 3x. Okay, and then 10 minus 3 is, I guess, a positive 7 here. So what we end up with is 3x minus 9 over 3x plus 7. And this would be our simplified form right there. Cheers.